Hey everybody, I'm Mr. Hartzler, and today we're going to talk about simplifying a rational expression. Keep in mind, an expression, there's no equal sign, so we can't actually solve it. We're just trying to condense it down or make it a little bit smaller. We have four major steps in that. Step one is going to be to factor the numerator and the denominator, so that's the top and the bottom of a fraction. The next step is to eliminate common factors or things that are found on the top and on the bottom of that fraction. Then we're going to simplify any little things that we have, like if there are 2 and a 4 on top, we should probably multiply them, folks. That's 8. Then we're going to state what makes the expression undefined. Well, what does make something undefined? Well, for us today, it's going to be where the denominator equals 0. We can't divide by 0, so we have to state that that can't happen. So if we have, let's say, 5 plus x on the denominator, we're going to set that not equal to 0 and solve from there. But you'll see as we go. All right, let's get started. This one here, we're going to simplify, and we're also going to state where the expression is undefined. So we have all of this first. You'll notice the top is factored, but the bottom is not. So we're going to factor the denominator. Numerator, I'm going to leave the same. And then let's look at the bottom. Y squared minus y minus 6. Well, that factors a little bit. And we end up with y minus 3. And y plus 2. Now, if you remember those steps that we talked about earlier, we're going to try and see what things are uncommon on top and on bottom. And we have y minus 3 on top and on bottom, so we can cancel those things out. You'll also notice we have a y on top and a y on bottom. Those two fellas cancel right out. Now I'm going to write what we have left. We have a 4, y plus 4, and then divided by y plus 2. So now we're on to step 3. We're going to simplify any little things. That's where we're going to distribute this 4 in. And we end up with 4y plus 16. And we're still divided by y plus 2. Now we're on step 4. So we're going to try and figure out where is it undefined? And that is wherever my denominator equals 0. So I'm going to pull that denominator out. And y plus 2. It's not allowed to equal 0. If that happens, the whole thing is undefined. So y cannot be a negative 2. So this here is my final answer, and this is us stating where the expression is undefined. Let's keep going with that. There we are. We're going to simplify, and we're going to determine where this is undefined. So you'll notice in this one, I have to factor both the top and the bottom. So let's get going with that. We have an x all the way on the outside, and then we have, let's see here, that factors to an x plus 2, x plus 6. Then the denominator, there's a negative 6 floating out there. We have x minus 5, x plus 2. Again, there's stuff we have on top and bottom that we have in common. We have an x plus 2 and an x plus 2. Well, those two things cancel out. We have a little bit of stuff left. I'm just going to rewrite that. We have an x and an x plus 6, and we have a negative 6 and an x minus 5. Now, before I do step 3, I'm actually going to do step 4 before step 3 this time. I'm going to find out where we're undefined, and that's because my denominator is still factored, and it's sometimes easier to find our zeros for the denominator if it's factored already. So I'm going to take that denominator out, and we're trying to find the stuff that is undefined. So I'm going to set my denominator not equal to 0 because it cannot equal 0. Then I'm going to solve for x. Divide by a negative 6. So x minus 5. Well, 0 divided by anything still going to be 0. Well, unless it's 0, then it's indeterminate. But anyway, still 0. Add my 5 over. X cannot equal positive 5. Awesome. That is where I am undefined. So now let's go back up here, and let's simplify this a little bit further. We're going to do that by distributing our x in and distributing our negative 6 in. So this, we're going to come down. We have an x squared plus 6x divided by negative 6x plus 30. And that is it. This cannot simplify any further, though I do tend to have some students that will try and cancel one of these x's with this x. You can't do that, folks. You can only do that if it's being multiplied to everything, like up here. All of these things are being multiplied. All of these things are being multiplied. So I can cancel those two things out. Since there's stuff being added and subtracted, I can't cancel it from just pieces and parts. All right, next one it is. This one, you'll notice it's a little unique. First, we're going to do the same thing as before, but you'll see that there's some extra fun stuff. We can factor something out of the top. Bottom's already factored. You'll notice at the top, though, it looks a little different. We haven't done this kind of factoring yet in this video, but this is just our GCF, or our greatest common factor. What do they all have in common in the numerator? Well, it's a z, so let's pull a z on out. I'm left with an x minus 4. Denominator, there's already I think I said x, but that's a z. There's a z squared, and then there's a 4 minus x down there. All right. Now, these two, they look a lot alike, don't they? X minus 4, 4 minus x. I mean, they just switched, really. So, can't I just cancel them? Well, no. And the reason is we have the commutative property of addition and multiplication, but not subtraction. So, we have to make these two things exactly the same. What I'm going to do now is I'm going to factor a negative out of this term right here. So if it's a positive x and I'm taking a negative out of that, well, now it's going to be a negative x, negative 4, and I factor a negative out, well, that's going to be a positive now. So let's double check real quick. Distribute the negative in. That's a positive x and a minus 4. All right, awesome. That's what I had here. My denominator, I'm going to leave it the same. Okay. Now this one, it seems pretty good, right? We have a negative x and a positive 4, or negative x and a positive 4. That still seems a little shady. So I'm going to reorder some of these things. That negative, it's multiplied to the z, isn't it? Well, yeah, so I'm going to just multiply that. So I have a negative z now. I'm going to leave my bottom alone, except I'm going to split up my z's. Z squared is the same as z times z. Then it's a 4 minus x on the bottom. So I have both of these in my numerator hanging out right there with the negative z. But negative x plus 4, there's a plus sign, and I have the commutative property of addition. So I'm going to move that plus 4 out in front and the minus x in the back. And again, that's kind of a plus a negative x there. Now these two are the same. Boom, gone like the wind. Then I have a z and a z. They cancel out. So I have a negative left on top and a z on the bottom because both of these canceled. But what's the number that's on top? It's still a 1. There's always a 1 floating out here. Just always. It's always there. It's in the front. It's in the back. It's wherever you want it. But there's a 1. So there's my 1. And that doesn't look like a negative. Now it looks like a negative. So I have a negative 1 over z. And again, it doesn't ask you, but z cannot equal 0 because that would make it undefined. Let's do this other one. I'm going to go a little bit quicker now. We can factor out an a and a b here. So a and b, I'm left with a b minus 5, my denominator, 5 plus b, and then 5 minus b. Again, these all look a lot alike, but I'm going to do this one over here, and I have to factor out a negative again, just like I did over here. I'm going to do that the same way. So I have an ab, and I have a b minus 5, 5 plus b. I'm going to factor a negative out of this one. There's a negative 1 I'm pulling out, and now it's a positive b in there and a minus 5. I also switched the order of those two. All right, so there's that. And again, commutative property of addition, I am able to switch those up now. They match up. Awesome. AB, 5 plus b, and a negative 1. Well, this is that step, I think it was 3 I talked about, where there's a little bit of simplifying. Let's multiply that negative 1 in. AB and a negative 5 minus b. Again, these b's can't cancel because there's not a b over here with this negative 5. All right, off to the next one, folks. Here we go. We're almost done. We're getting close. I have, this is my last one. So we're going to talk about multiplying over here and then dividing over here with rational expressions. These can be kind of tricky, so just take it slow, be careful, and just really take your time. Don't get overwhelmed because really none of this is that challenging. We're just adding a lot of steps into one problem. But all these little steps you've done before. All right, what I'm going to do with these is I am going to multiply everything together, then I'm going to start simplifying. When I'm multiplying, we just multiply straight across, numerator to numerator, denominator to denominator. None of this cross-multiplying stuff. Don't do that. That's only if there's an equal sign and you don't see an equal sign. So we have 12 times c cubed times d squared, and then it's times 14 times a squared times b. I'm going to reorder that a little bit as we go, and I'm going to put the numbers together first. So 12 times 14. I'm not actually going to multiply those. If you're one of my students, you're not going to have a calculator, so you're going to have to do the simplifying long way. So there's no point in multiplying if I'm eventually going to cancel some stuff. Then I'm going to put my a's first because I'm weird like that, and then b's, and then c's, and then d's. Same thing on my denominator now. I'm multiplying all of these things. I'm going to move that 8 over by my 21. That's okay because the commutative property of multiplication. Now I'm going to try and split these things up a little bit better. I see that there's probably some A's, B's, C's, and D's that are going to cancel, but it's kind of hard with the 12, 14, 21, and 8. So I'm going to split that all up. Well, 12, maybe I can get some of that to cancel with the 8, so I'm going to split it up into like a 4 and a 3. Okay, so that used to be the 12. Now it's a 4 and a 3, because 4 times 3 still gets you 12, so we're good there. 14, well, that's let's do a 7 and a 2, because there's a 21 down here, and a 7 is going to be in that 21 as well. Then I'm just going to list off all of these things that are still in my numerator. Now I'm going to split up the 21. We have a 7 and a 3. And the 8, we have a, let's see, a 4 and a 2 in there. And then we still have an A, a B, a C squared, and a D. Now you'll notice everything's multiplied everywhere. So we don't have to worry about, can I cancel that, can I not? You can cancel whatever looks like it can cancel. 4 and 4, awesome. 7, 7, cool. 3, 3, 2, 2, beautiful. Just like magic, except magic's not real. Then let's look at the B's first because they're nice and cute. B over B, well, they cancel. I have A squared over A. One of those cancels. I'm now down to A to the first instead of A squared. Instead of A cubed over A squared, well, now it's just a C to the first now. D squared over D, that cancels, and there's only D to the first now up top. So you'll notice everything in the denominator canceled. I'm left with A, C, D. Almost A, C, D, C. Anyway, that is it for that one. No denominator or anything at all. Awesome. Let's go over here to where we're dividing now. When we're dividing, that's the same as multiplying by the reciprocal. Okay, so I'm going to kind of flip that over. Sorry, this video ends up. I'm at 12 minutes and 49 seconds now. Craig might be able to cut some of that time out, but whew, it's getting long. First thing I'm going to do is just rewrite this so that I'm multiplying the right stuff. So again, dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So we can put the 16 on top, the a squared on top, and the x on top, and 6x squared y to the 4th is on bottom. Now we're going to do the same thing that we did last time. We are going to try and split all of this up, kind of reorder it a little bit, and make everything look nice and neat. So this 12, I'm going to split it up into, let's see here, it's a 4 and a 3 gets me a 12. Okay, so that's where that went. Let's do the 16 now. And I'm going to do a 4 and a 4 for that one. Then I'm going to put my a squared first because I'm just enough obsessive compulsive that I like that first. Then I'm going to put my x's because, again, why not make it alphabetical? Ooh, lights just shut out. But we have a lamp, folks. And y to the 4th. Awesome. That's everything from the top, right? My 12, my 16, x. Ooh, we're missing that x to the 4th. Okay, well, x to the 4th and an x, that gets you x to the 5th, y'all. And then we have a y squared. I'm messing this up all over the place. And then a y squared from there. So we have our 12, we have our 16, a squared, x's, we combined them, we got x to the 5th, and then we had y squared. Now the bottom, the 40, let's split that up into a 4, and it's actually, we're going to want to split it up into a 2 and a 5 as well. 4 times 2 is 8. Times 5 gets me the 40 that I want, but I split it up a little bit more than you might have thought. Next, we'll do the 6, and that one's going to be a 2 and a 3, just like you would suspect. Then we have a to the 4th, b to the 4th, x squared, y to the 4th. And let's see what can cancel here. Some 4s, and, ooh, okay. This 3 here. You see this 2 and this 2. What is 2 times 2, folks? Well, that's 4. Boom. Gets that one. So both of these are now gone, made up of that 4. Then let's look at our, oh, I turned that a little bit. There we go. Look at our a's. We have a squared over a to the 4th. Well, I'm now left with a squared on bottom because it was a 4. 2 of them canceled. I'm left with 2. For my x's, I have x to the 5th on top and x squared on bottom. I'm left with x to the 3rd on top. Y squared and y to the 4th, I'm left with y squared on bottom. Okay, so sorry, this x is now gone because it canceled there. All right, let's see what we have left here. Cancel, cancel, cancel. 4. Cancel x cubed. Y is canceled, okay. Bottom, we had a 5, a squared, b to the 4th, y squared. I know that can be a little confusing, sound a little bit tricky, but again, just go slow, break things down to their smaller components, and then start lining some stuff up. In here, again, we had a squared over a to the 4th. And we can split that up into a over a, and then, 4 of them down on the bottom. That one cancels with that one, and that one cancels with that one. I'm left with an a squared in my denominator. So I know I went through that kind of fast. So I took some assumptions there, but that's not too bad. None of this is terribly scary. Just have to take your time and kind of chug along. Alrighty, folks, this ended up being almost 17 minutes, but that's all I have for you. Please like this video if it was helpful. Subscribe to the channel if you want to see more of them. And down, it's going to be over here. There's a little bell icon next to the subscribe. If you click that, you'll get notifications when I put up new videos. And I also organize all of this on my website. My website is www.mrclayhartzler.weebly.com. So you can check that out if you want to see all of these videos kind of organized with some of the guided notes I have. Have a great day, folks, and enjoy it.